So I'm happy today to have Troy Walsh with us from Magenic. He is the National Practice Lead for Magenic Technologies Quality Assurance and Testing Division. He's also a frequent blogger and speaker, and he has a passion for test automation and DevOps, and he's going to talk to you guys today about making .NET automation awesome. Welcome.
Okay. Let's get started. What's that? Oh, the advancer. Nice. Okay. Sauce.NET, making .NET automation awesome. We'll skip that part. So a quick overview of what we'll be covering. First, we're going to define at least what I think of as awesome automation. And then we'll talk about picking the right tools based off that criteria. And then we'll talk a little bit about our demo stack. So we're going to be talking about .NET. So what does that mean from a practical standpoint? And then one of the things that we'll select is Sauce Labs. And we'll talk about why Sauce Labs is a good fit for this. And then we'll demo. We'll kind of see the sausage being made. So first thing, good, awesome automation is just good code. If you are writing test automation and your code is bad, your automation is going to be bad. Don't expect to get something really good from lackluster code. And this means a couple of things. This means having good coding standards, good object-oriented design. You can't just write a bunch of procedural scripts and say, oh, this is going to be awesome. It's totally not. And then you also want to make sure that it integrates. And it integrates in three distinct ways. First, it should live in the same place as your application code. They should live side by side. This prevents you from having siloing. Right? You don't want to have your automation code running over here, your application code running over here, and you can never quite sync them up. If those get out of sync, you're basically wasting your time. You also want to make sure that your automation code can be part of your CI/CD pipeline. If it's not part of your pipeline, you're probably not even going to run it. And that's not cool. You also want to make sure that you have reporting. And this is reporting from the CI/CD perspective and from the test management perspective. For the most part, you don't really care if you're testing something manually or in an automated fashion. You care that it's getting tested. And I can guarantee your manager only cares that it's actually getting tested. So that single source reporting makes your life way simpler. You also want to make sure that your automation is configurable. And this can be a lot of different things. This can be the application that you're testing. If it's a web app, your dev versus your stage versus your QA, these will have different URLs. And you don't want to write brand new scripts for those. You also don't want to write brand new automation for a completely different browser or OS combination. That's silly. It's a waste of time, especially when you can use configuration to address that. You also want your automation to be parallelizable. If you can't run your tests in parallel, you are going to run into big problems very, very, very quickly. It doesn't take long before your test suite starts to take hours, and then multiple hours. I've actually had test suites that have run more than a day with parallelization. And you can't do that in a CI/CD world. You have to have that parallelization built in. And this last point, it's a small point, but very important. You want your automation to be fixable. And this means a couple of things. One, you need to know how it actually works. But you also you don't want to be stuck with waiting on a vendor. You don't want to say, okay, this vendor is going to have this fix out for us in 6 months, and I can't do anything in the meantime. And that's actually one of the big reasons that I love the open source community, especially Selenium for the browser. Because when something breaks, I can go out and I can pull down that change request and actually implement it myself. So I'm not dead in the water. So how does this actually kind of wash out? So we've set the criteria. Now, how do you pick your tools? First thing, you want to make sure that whatever tool you pick is built on top of a testing framework. And this is distinct from Selenium, Appium, those kind of testing frameworks. This is more of a unit testing framework. I'm specifically saying unit testing framework because those can integrate with your CI/CD pipelines. The distinction between a unit testing framework and a testing framework is usage. Right? It's the context of what you're doing, not the tooling. Just because something can start a test and end a test and give you a good or bad, that doesn't specifically make it a unit test. So you really want to build off of a unit testing framework so you have that nice integration. And also, you also get the nice reporting. And you'll see in VSTS that the integration with the test management tool is pretty much seamless. You also want your application testing framework, and this is the Selenium, Appium. How are you interacting with that thing that you're testing? And those will live on top of your testing framework. You'll also want to make sure that it can test the stuff you want to test. If there's something that only works with IE and you need to test Chrome, not a good fit. And this is one of the reasons that you kind of go back to Selenium, Appium for a lot of your testing. You also want to make sure that it works with your tech stack. So in most development projects, you and your team have spent a lot of time and effort building up that tech stack. If you're a Java shop, you've got Jenkins, you've got all of this infrastructure, you have all of this fixed cost that you've already put in. It's very rare that it's a good idea to go with something other than Java in that case. Or if you're a .NET shop, probably want to go with C#. You don't want to come in with Ruby because there's extra cost associated with that. And you really have to get big benefit before you've actually paid for that opportunity cost. And ideally, going back to, it's ideally open source. So you can fix it if it's broken. And last but not least, you want to make sure that you can remotely execute. If you can't remotely execute, you are very quickly going to be stuck to one or a handful of machines. And this really hurts your parallelization. It also locks you into weird things that make your automation kind of terrible long term. So for this tech stack, we're going to be using C#, because we're talking about .NET. Primarily, that means using C#. You can use VB.NET. Don't use VB. Just don't ever use VB. There's no excuse for it, any of you. We're going to use VSTS. If you're not familiar with VSTS, this is, you can think of it as kind of the full Atlassian stack. So it's basically Jira, Git, Bamboo, and test management tool all bundled into one thing. VSTS is the online version of Visual Studio Team Services. So instead of you hosting it, Microsoft hosts it for you. So it's kind of the latest and greatest Team Foundation server. And it takes like 2 minutes to set up. It's awesome. We're also going to be building on top of VSTS, or VSTest. VSTest is the unit testing framework for Visual Studio. This integrates really, really nicely with all the other stuff in VSTS. If you're going to use something else, you're going to have to build out a bunch of custom components in order to get the same benefit. Yeah, there are people that are like XUnit or NUnit. Those are no. It's going to cost you more time to use those than any gain you'll ever get. And then we're going to assume browser-based testing. So that means, in this case, that means Selenium and Sauce Labs. So why Sauce? Well, first reason, let's talk about what Sauce Labs is from a very high level. It's grid, right? It's somebody else builds and maintains a grid for you. You're paying to use it, but that's it. Right? You don't have to patch the system. You don't have to worry about when it runs out of memory. You don't need to update all the web drivers. There's a lot of hassle involved in that. And I know from a consulting perspective, the amount of money that you have to pay to get something like Sauce Labs versus what it would cost for me to build grid for you, I'm not going to beat Sauce Labs. I'm just flat out never going to. It's a money-losing situation. You're much better having me actually creating your automation as opposed to building this out for you. In order to use sauce, there's only really four pieces of information you need. You need the username, and of course this assumes that you have an account. You need the access key, so basically username, password. What browser you want to test against, and the URL to Sauce Labs. That's all you need. Once you have that, you can start pointing your tests at Sauce Labs. But that's a little simplistic. This would be okay when you're starting out on a project, but this is by no means enough. There's other information that you'll want for most of your projects. And I'd say this kind of covers 95% of what you're going to want. You're going to want to be able to say not only what browser, but what version. This is especially important when you're talking about IE, because IE 10 and IE 11, not the same thing. You're also going to want to define what platform. So what operating system this is running on. So Safari on Windows is not the same as Safari on iOS. That's not the same as Safari on other operating systems. With responsive design, you might want to define your screen resolution. That's a common need in testing. And then there's these two last pieces, the name and build. These are critically important. Regardless of what language you're using, if you're using Sauce Labs, use these or you're shooting yourself in the foot. What this does is it categorizes your tests, so it will actually associate them with a specific build, so you can actually find them later, and you give it a name that you can find. Otherwise, it's this big, nasty GUID, and good luck figuring out what GUID relates to your actual test. Kind of a nightmare. And then in your teardown, you will actually mark the test as passed or failed. There are other result types that you can get in here. I'm just using anything that's not pass is fail in this case. 90+% of the time, that's good enough. But if you want to really put in some effort, you can go and figure out what all those flags are. But, yeah, more or less good. But there are more options. I won't go into these in great detail. I'll skim over most of them. Just know that there are a bunch of other options. These are some of the more used ones. There's also a list of other ones that are just, I've never actually seen them used out in the wild. This first one, tunneling, we'll talk about tunneling in a second. This allows you to say what tunnel to use. So you can have named tunnels, and you can decide which one to use. Time zone, that's pretty self-explanatory why you might want that for your testing. When you have a tunnel, you can also say, do you know what, avoid that, don't do proxying in this case, also an option. And then various options for turning off logging, turning on logging. It's kind of whatever's right for your project. Maybe there's information that you don't want screenshots for, or there's some log information you really you want the test to run there, but you don't want that saved off for some reason. And then you can set test priority and some of the exception handling. So one of the big issues that you run into when you're doing test automation, especially when you start looking at using a cloud-based provider, is access. Can I actually access my test system from where I am? And a good share of the time, the answer is no. These test sites are intranet only. Your client, your company doesn't want these to be accessible from the outside world. So traditionally, this would be a problem. But there's a tool called Sauce Connect. Sauce Connect, it sets up this tunnel. And it's configurable. Actually, this could be a talk in and of itself on all of the capabilities of Sauce Connect. Just know it can create a tunnel and you can name it. So you can decide what tunnel to use. Or you can use a modern compile server. Be that VSTS, be that Jenkins, Bamboo. They all have extensions to be able to use Sauce Connect. So it can just be built into your CI/CD pipeline without you having to do anything. So let's go to demo. Okay. So first thing, this is an example project where I have both a web application and the automation. You'll note they're living in the same code repository up on VSTS. This allows us to do automation in Sprint. So it allows for you to write your automation at the same time that you're writing your features. Very nice. And then it allows us to also create artifacts for both. Artifacts being, when I build these, they actually compile down to something. And I want to be able to package those together. I want those to be in lockstep. So I know exactly what I'm testing with and what's being tested. Gets rid of all the ambiguity. Nice. So let's look at the code quickly. So the code. What we have here is we have a .NET framework. What we've done is we've abstracted all of the setup, teardown, any of that configuration stuff. That's saved off somewhere else. Right? You don't need that in your test. You don't want that in your test. It's a terrible idea for that to be in your test. So we're abstracting that out. And then we're using a basic page object model. Right? Your page object model can get more or less complex, and you can use a couple of different design patterns, but idea is basically the same. But then we can also get coding standards, all that kind of stuff that you want to have good, reliable code. As far as our configuration goes, we're moving our configuration into a config file. This allows us to not only have the configuration not hard-coded, it allows us to override those settings. So when we're actually running these tests, we can decide at runtime, I want to do IE instead, or I want to do this on Windows 7, and then I can report specifically on those. And we'll see how that works in just a minute. So yeah, all these values will override pretty much all of them based off of our CD. Okay, and for our teardown, you'll see right here, we're calling JavaScript to let the system know, did it pass, did it fail? Nothing really special with the code. It's just a JavaScript execution. It's totally not legal JavaScript, by the way, so if you use it when you're running locally, it'll bomb out on you. I find it irksome, but that's the way it works. And we have a bunch of tests here. I'm actually going to make one of these tests fail, because when you're doing a demo and everything's green, that's boring. I hate it. Because green's easy. I can just get rid of all the code and it'll just be green. Okay. Yeah, let's be a goodish person. So that change is going in now. Let's see, where's my mouse? Yes. Believe it or not, this is harder than it looks. Okay, so I just checked in code, and I can do a couple of things. So if I have a really robust CI/CD pipeline, I will do a gated build. So gated build, that will actually prevent me from checking in code that doesn't compile. Right? I can set rules saying, yeah, your code, it doesn't live up to the coding standards, it doesn't compile, the unit tests fail, we're not even gonna let you in. That's what I do for a normal project. It's kind of hard to do in a demo, so I've completely skipped that part. So pretend that happened. And what you'll see is we had this build going, and we have a build that just happened. And this got triggered because we checked in code, so now there's a new build artifact. So what the build artifact does, or what the build does, is it builds, runs our unit tests, and then creates the artifact for us. Nothing really out of the ordinary here. The next piece is we'll hook this up to our CD pipeline. So we can set up a pipeline for what does continuous deployment look like. This is a nice visual of what exactly your pipeline looks like. We have things called triggers and gates. So the triggers are the lightning bolts. Something happened in the system. When something happens in the system, it triggers the next thing. So in this case, we have a new CI build that's automatically triggering a deployment to our continuous test environment, and it's also running through our tests. I didn't have to decide that these tests should run, and I shouldn't decide whether these tests are run. This just happens. There's no thought. There's no maybe we don't do that for this build. It's a non-event. It's just the way things work. And we'll look at the steps here. The first thing that we'll do, we will set up our SOS connection because this is a website that is not available from the outside world. So if I tried to go to that site from right here, I can't get to it. But my compile server can. So we use SOS Connect to get that. We deploy our new application. And this can be MS Deploy, this can be Azure, whatever mechanism you use to deploy your new application. And then we are updating our configuration. So we're saying, we have this artifact. Only thing that we need to do is update the configuration so we know how we're running it. So in this case, I'm saying, I want to run this against IE10 on Windows 7. So I'm overriding a couple of these values, one of them being my access key. I don't want my access key in my source code. That's as part of my variables. So you also have access management as to who can actually look at these things. It'll go through. It will run the test. Couple of really awesome things here. I want you to note that I have a test plan here, so I can explicitly say, I want to run tests from this test plan. Not only that, I want to run tests from this test suite. So it'll go to my test suite and say, okay, what tests are there? What automated tests are there? And then it will actually go and run them for you. Another cool thing that you have is using a test settings file. You can decide what kind of parallelization you want. In this case, I have it set for my highest concurrency. So I have 25 VMs, or 25 concurrent sessions I can have. So I'm putting that sucker up to 25 so I can plow through my automation very quickly. Oh, and then it just kind of repeats going down so I can get through that full stack of, okay, here are the browser OS combinations I want to do. And then the very last piece, well, I want to clean up after myself. I don't just want to leave a proxy open on my compile server. It's just rude. It's bad manners, if nothing else. So we take care of that. So remember, I checked in some code, and I checked in code that failed. And I knew it was going to fail. So I go in here, I look at my test run, and this is all configurable. So I can say if any tests fail, it just fails, or I can make it conditional based off of whether I want it to continue or not. So we see, yeah, we had tests, and a couple of them failed. Those are the failed tests. I can dig down and get more information on them. So I can say, yeah, okay, that failed because there was an assert failure. So that's pretty good. I can also decide whether or not I want to promote this. So this is actually really, really, really nice when you have automation working with your manual testing team, because automation can just keep running. Right? As soon as it's done with one, it just takes up the next. It doesn't care. It's not paid by the hour. It's just as happy running automation as anything else. But your manual team now gets to decide, is that horrifically broken? Is that really something that we want to spend the time manually testing? So this allows for that better integration between your manual and testing efforts. And let's refresh. So what you'll note here is most of these tests passed, except for these right at the bottom. So those are those failed tests. Those are the ones that I explicitly made fail. The other thing you'll note is, remember the build number that we had? It is very specific. This failed for that specific build. There's no question what build this was for, when it failed. And I can intermingle this with my manual tests. So I can say, okay, manual testing, this is what they need to do in order for this regression suite to be done. So I can do that all in one place. And then I can break it up by different configurations. I have a lot of things that I can do there. But this entire process happened just from me uncommenting one line of code. That's all it took. So the last piece, let's pull that up. Remember I said that you really want to define your build number and your test name? If you don't do that, your life is going to be terrible. If you do, you actually have something that's readable. You can easily go in and say, okay, that was a build number. I already knew that was a build number. I can go, oh, okay, the 3 tests. I can filter on those tests, and I can get all of the information that I want or need from sauce. It's just ready there for me. So, questions?
Why did you choose to use VSTS over a unit? Yeah, sure. Well, yeah, why do you have to choose VSTest over in unit? Why is that a profession?
You don't have to, but if you don't, that integration with the test manager, you have to build that yourself. I built it myself. It's fun. Once again, way more expensive than it was worth, but yeah, totally doable. The other piece, so then there are 2 pieces to that. One, you actually have to build your own custom probably PowerShell in order to link the test cases, because in Visual Studio they won't link up if it's NUnit. Then you have to write your own PowerShell in order to upload them on the back end, because you have to mess with the test result file. So there's like a magic GUID underneath that says how tests line up. It's fun to do. It really is. Cool.
So if you go back to the test tab, so you had a configurations column.
Yep.
So you had different configurations. So how did you get that?
Oh,
Like the configurations, because when you're running automated tests, I'm just wondering, like, how did you actually get that?
Oh, I can define whatever the heck I want. It's just built into the tool. I can put together n number of things, and they count as a configuration.
Isn't that something that's managed in the config file?
So I have to update the config file to match with the test run that I'm doing. So those 2 pieces of data need to match up. That's why I do the configuration update followed by the selection of the configuration.
So this is a manual update, not just coming from your config file.
Scripted update. Yeah, let me show you. So like right here, we're coming in. I'm specifically saying this is Windows 7, IE version 10. And then when I come down to the test case, I'm selecting IE 10, Windows 7. So I make sure that those 2 line up.
So how did you choose what tests to run on what configuration? Are you running all the tests on all the like in this configuration?
Oh yeah. Actually, that's a very good point. You can run whatever tests you want. You can do filtering. You can do a bunch of different things in here. For this demo, I just ran all of them because it's a bunch of tests and they take no time to run. But yes, in a production or in a realistic environment, you'll probably do some filtering to choose better tests for different environments. You might not want to run regression every single time that somebody checks in, but you're probably going to want to run smoke every single time. You might want to wait for regression to run when you're deploying to your QA environment.
And you suggest to run all the tests in different configurations?
Oh, what's that?
So you suggest to run all your smoke tests in these configurations, this test configuration?
That depends entirely on the application, who the user base is. If you're doing, it's very different whether this is going out to the whole world or whether it's inside an organization. Like this is a internal app and the division said, you're supposed to use Chrome. We might test other browsers, but we're not going to test IE6. But if it's international, IE6 is probably going to happen. Cool. Thank you.